Hi class, I'm now in application of trigo bearings, which is worksheet 2. I'm now going to continue and finish up this worksheet. So now I'm at example 3. So let's read the question first. A bird flew 29 meters on a bearing of 56 degrees from A to B, okay, and then flew 16 meters to C. Given that angle ABC is 145 degrees, we need to calculate the bearing of C from B first. So part A. Okay? So I want C from B. So from B means I have to draw a north at B. So let me just draw a straight line up from from B first, then label it as north. So what I will do here, I'm just gonna put a dot and call this point D for easier angle reference, okay? Okay, so let's examine this diagram here. Notice something, I have a C, okay? So I have a C here. Angle DBA, this orange color angle DBA plus this angle 56 degrees will be equals to 180 degrees. This angle property is your interior angle property. So let me just write here first. We need to find the orange angle first. So angle DBA equals to 180 minus 56 degrees, which will give you 124 degrees. This is your interior angles property. Okay? So now, take note, bearing of C from B, we need to measure clockwise from the north. Okay, so the north at B is here. So from B to C, so you draw clockwise until you meet the line that connects to C. So this is the bearing you need to find for part A. Notice something, I already found the orange angle, which is 124. I have 145 degrees. To find part A bearing, you just need to take 360 minus 124 minus 145. So let me just write here. Bearing of C from B equals to 360 minus 124 minus 45 degree, 145 degrees, and you will get 9. Take note, 091 degrees, because for bearing, you write it as a 3-digit. Okay, you express it as 3-digit. So bearing of C from B, 091 degrees. Now let's go to part B. I'm going to erase the highlightings here so that you won't be confused. Okay, I want to find the distance AC. Let me highlight in blue. Oh, it is opposite the included angle. 145 degrees is included angle because it is in between two known sides, 29 meters and 16 meters. So we can use cosine rule. So let me just write the equation of cosine rule first. Okay, so I want to find AC. So AC will be my small letter A on the left. Okay, B, I'm just going to put 29. C, I'm going to put 16. So just substitute as such. So cosine, angle opposite the length AC will be 145 degrees. Okay, you can pause here to square root and then play to get the answer that I will write. Okay. Okay, the answer for AC will be 43.9 meters to 3SF. You can write this in 5SF first, 43.095, just in case there are future parts to this question. Here don't have, but in exam, try to leave it in 5SF first before rounding it off to 3SF for length and 1dp for angle. So this is how you do example 3. Okay class, now let's look at example 4. Let's read the question first. A house B is 400 meters due south of a shop A. So here is my north. So south is the other direction, opposite direction. So notice that, yes, B is due south of A. Okay. Bearings of a cafe C are 115 degrees given already and 41 degrees from A and B respectively. Okay, so take note, bearings are all given, angles given. There's a 400 meters label there. Find part A, distance BC. I'm going to highlight BC first. BC is this blue color length, okay? We need to find some angles first, okay? Let me write here, part A. Notice I can find angle BAC. Angle BAC in 115 degrees, they lie on the same line. So we can take 180 minus 115, 65 degrees, adjacent angles on a straight line. Okay, so this is 65 degrees. Next, we can also find angle ACB. Angle ACB is in the triangle, and you have two other angles known already. So 180 minus 65 minus 41 degrees. Take note, bearing right in 3 digit, but angle right in 2 digit, yeah? Okay, so you'll get 74 degrees. So this is sum of angles in a triangle. Okay, can okay, so now I have found all my angles. I want to find BC. So let me do something. 65 degrees is opposite BC. Okay, 74 degrees is opposite a known side of 400 meters. This we can use sine rule. So BC over sine 65 degrees equals to 400 meters over sine 74 degrees. Please help me to do your own calculation for this. I'm sorry, for the intermediate step, please help me to do. BC, you will get 377 meters to 3 SF. So the intermediate steps, please help me to write on your own. Okay? Now let's go to part B. Shortest distance from C to line AB. Notice the dotted line already drawn for you. Shortest distance from C to the line AB is always the perpendicular height. So I'm going to label a right angle over here. I repeat again, shortest distance from C to the line AB is perpendicular to AB. Okay, so now I'm going to do a bit of highlighting. I'm going to erase the blue one. Using my yellow highlighter, I'm going to highlight a right angle triangle. Okay, a right angle triangle. I found BC already. Okay, so take note for your BC, please help me to find the, 5 SF value first. So find the 5 SF value. And then your 3 SF value is 3 in 3 SF, 377. You need the 5 SF value to substitute in part B. Let me show you why. I have a right angle triangle. BC I found in part A, 5 SF value. Okay. Notice I have an angle here, 41 degrees. I want to find perpendicular height. This red color laser length I'm doing. Okay. So this is my opposite. Okay, opposite my right angle is the hypotenuse. So let me label, this is height and this is op. So I can use sine ratio. So sine 41 degrees equals to the perpendicular height. So I'll just write here perpendicular height over your 5 SF value of BC. So I'm just going to put BC here. Please help me to substitute on your own. So substitute this 5 SF value into the denominator. Okay? Can So the perpendicular height, you will get to 3 SF, 247 meters. Please help me to write your final statement. Shortest distance from C to the line AB is 247 meters. So this is how you do example 4.